is all points that are equidistant from a point called a center. If you think of how the way your compass works, you put the needle here, right? You have a radius opening. Look at your compass, that's open to the radius. And then if you spin it, it makes a full circle. And so that each time you're spinning it, you're still equidistant from that center. And because of that, there's a lot of great math that happens with circles. Wonderful math. Okay. A segment whose endpoint's on the end of the circle on any point on the circle is a radius. How many radii are in a circle? How many segments can I draw from the center to the edge? Even more. Even more. Infinite. There's infinite amount of radii in a circle. So think about a bicycle. Can you all imagine a bicycle? Are y'all thinking about it? The wheels, aren't there spokes that go from the center to the edge on the tires? Those are called spokes. Each one of those spokes are a radius. What about those spokes? Are they all equal in length? Is every single radius going to have the same measure? Yes, they have to. Look at how much we learned already, and I hardly even talked. So all radii are congruent, right? So if MZ is 4 units, what other segments are also 4 units long if M is the center of the circle? So right now, look and see how many radii are in the circle and label them 4 units. Go ahead and do that. Have pencil in hand. Label your radii 4 units. How many radii are there? I see 1, 2, 3, 4. I do not see 6. Z, Y, and WX are not radii because they're not coming from the center. So how many are there total? 4. You have one here, MW. You have MX. You have MY. And MZ was given. So that's a total of, 4 radii. Why are ZY and WX, why are they not radii? It's not coming from M. It's not coming from the center. Radii have to come from the center. Let's try this again since we were confused. So AB is 3 units. What other segments are 3 units? Well, ones that are drawn. 1, 2, 3, 4. AG did not go to the end. Right? Yeah, AG did not go to, you have all of this that it didn't connect to. So the only ones were AB, AD, AC, AE. Okay? Now a chord. It's not like singing, a chord and singing. It's not like a chord like a piece of string or length of, this is a new chord to add to your vocabulary. It's a segment whose endpoints are on a circle. So it's not going from the middle, from the center. It's on the end, it's on the circle itself. It's on the circumference, the outside. You should have drawn chords to try to find the center of a circle, right? By the way, archaeologists use that same construction when they find. So, everybody here know what an archaeologist is? Do you know what Indiana Jones was an archaeologist? Okay. So, if they find a partial platter dish or something that is curved and they want to know what the original size was, they will do the same constructions you all just did. They would outline the curve, draw two chords, find the perpendicular bisectors, and then draw what the original circle would look like. So then they'd have an idea of how big the original platter was. So they would use pieces. So we will be doing that, but I'm not going to give you platters. I took a bunch of cottage cheese lids and different lids and I cut them. And then you're going to try and find the original. That's going to be part of a project because I have a whole construction project that goes with the Pictionary dictionary. Okay? So, a chord that contains the center of the circle is a diameter. So, a diameter is a chord. Okay? Because the end points are on the end. But it's a special chord because it goes through the center. It's also the longest chord. It's going to be the longest chord of your circle. Guess what? All diameters of a circle are congruent. So, let's list all the diameters. Okay, hold on a minute. Let me do this. Let's see. You guys are giving me a headache. Okay, here's one. That's not what I wanted to draw. I wanted to draw this. So you told me PQ? I heard PQ. I heard PQ. I hear RS, XY, AB. Okay. And QP and PQ are the exact same one, right? So there's 1, 2, 3, 4. Because then the others are the exact same. And all of these have the same length. They are all congruent. So if PQ was 5 units, RS is 5 units, XY is 5 units, AB is 5 units, right? Okay. Now, the center of the circle is point A. The diameters have length of 10 units. Which segments are diameters and label their lengths? So, how many diameters do we see here? 2. There's 2. Which 2 are diameters? CB, CB, and DE. And these would be 5 units, right? So CB is 5. No, it said 10 up above. Sorry. Boop. It's 10 because it said they were 10. 10 and 10. Why isn't HB a diameter? Yeah, it's not going through the center. So what is HB? A chord. Chord. What's FG? FG? FG is also a chord because it didn't go through the center. Yay or nay? Got it? Okay, secant. A secant intersects the circle at 2 points. It passes through the circle. A secant passes through the circle at 2 points. Secant. Yeah. Now, a tangent is what you just drew. A tangent only touches the circle at 1 point. And that point is called the point of tangency. And you constructed these if you were here yesterday after the quiz. And if you were here on time, you had time to do it. Right? Okay. So here's just a visual of all of them. Except radius is hard to see because it's in yellow. Chord, radius, diameter, secant, tangent. Do you see it? Okay. Tell whether the line, ray, or segment best described as a radius, chord, diameter, secant, or tangent of a circle. So what's AC? What am I going to write for AC? That's a radius. What's DE? Tangent. What's AB? What's AG? No. It has arrows at the end. Secant. Secant passes through. It's not just the end points, it actually goes through the circle. Oh, here's all the answers. I thought I did. Okay, circle A is the blue circle on my screen. It's the first circle on your paper because yours isn't in color, right? So what's the length of the radius? If this is it's 1, 2, 3. So what's the diameter? 6. What about circle B? What's the diameter? Boy, you're all geniuses. Okay, now we get to learn some theorems. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius of the circle that's drawn to the endpoint of the circle. Okay, so when you drew your tangents, you could check with a protractor if you're totally accurate. From the radius to your tangent, this should be 90 degrees, right? If it's not, then you did something wrong. You weren't like really accurate. So, in the diagram, PT is a radius. Is ST tangent? It's not telling you it is, it's asking you the question, is it tangent? To check to see if it's tangent, you want to see if this is a right angle right there. If it is a right angle, then ST is tangent. If it's not a right angle, then it's not tangent. We can use the Pythagorean theorem to check to see if it is tangent or not. Okay? So, this would, remember Pythagorean theorem? Do you all remember this? And the converse says that if a squared plus b squared equals c squared, then it's a right triangle, right? And that's what we're going to check. So we're going to check, does 12 squared plus 35 squared, does it equal 37 squared? If it does, then it's tangent. If it doesn't, it's not tangent. So I'm going to use my handy dandy calculator. And I know that 12 squared plus 35 squared, and I add those together, it's 1369. Now I'm going to check. Is 37x squared the same thing? Yes. So is it tangent? So we would say ST is tangent to circle P. Or I had the P in the wrong spot. Ah! Let me change that. Circle P. There. You thought you were done with Pythagorean theorem. And I bet you thought to yourself, why in the world would we use Pythagorean theorem when we're talking about circles? I thought that was only for triangles. Right? But it isn't. Okay. This one gets a little bit tougher with the math. So I'm still checking a squared plus b squared equals c squared, right? A would actually equal r. B would equal, no, because here would be the right angle. B would be 80. C is this whole segment. What is this whole segment? Not 50. 50 is from here to here. There it is. 50 plus R. So now we're going to do the Pythagorean theorem. R squared plus 80 squared has to equal 50 plus R squared. I square 50 plus R. I need to do 50 plus R times 50 plus R. I have to actually FOIL that out. So that's going to be 2,500 plus 50R plus 50R plus R squared. So we would get on this side would be R squared plus 6400. This one would be R squared plus 50R, no, 100R, because I was combining my like terms, sorry. Doop, 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 100R plus 2500 equals R squared plus 6400. How do I solve this? So I'm going to have to get one side equal to 0, correct? So I'm going to, well, actually, if I subtract R squared, what happens to the R squareds? They cancel out. And I'd be left with 6400 equals 100R plus 2500. Now what do I do to both sides? Yep, I'm going to subtract 2500, subtract 2500, and I left, what is 6400 minus 2500? 3,900. is equal to 100R. You divide by 100. Oh, divide by 100. R is equal to 39. Divide by 100 on both sides. Oh, can I fit that in there? Okay. Some good algebra. We are going to be factoring. Now, today's homework doesn't have any of these on them. Next week's, I'm going to make sure that we get some. And the reason why I'm going to include stuff on factoring is I have, if Mark returns, I have 3 students in here who have to go to Algebra 2, and you took a break from factoring. So I'm going to do a quick review on factoring. And then I have some people in here who may go to Math 136. And Mr. Adam asked that I review factoring for those who are going to 136. Does that make sense? Okay. Did it all just worked out for you? It's all worked out right here, nice and neat. Okay. Okay, tangent segments. Do you think ophthalmologists know some of these theorems, by the way? People who work on your eyes? You think so? I think they would have to know some of these theorems. Yep. People who make eyeglasses, do you think they have to know a little bit about some of these things? Maybe. Okay. If I have a point outside of a circle and I draw 2 tangent lines, it turns out that those tangent segments, not lines, sorry, tangent segments, turns out each of those tangent segments will be equal. Okay? So what I mean by that is if this is 5, what's this over here? 5. How easy is that? So how would I solve this if I want to find x? Yep. And of course, to solve this, I would subtract 4. I get 24 is equal to 3x. I divide by 3. X is equal to 8. Mr. Adams is supposed to be stopping by. I'm trying to listen because usually you can hear his jingling of his teeth. Yeah. Okay. Perimeter. What is perimeter? All the way around the outside. We agree? And it says here, assume that lines which appear to be tangent are tangent. And they want to know the full perimeter. The problem is we're missing a piece. Does everybody see here that we're missing? We're missing this piece right here. So to be able to figure out what this piece is, I know, because I am smart, and you are smart also, that if this is 13 here, then this piece is 13, right? If this piece is 13, is there a way for me to find this over here? No? There you go. 25.4 minus 13, because this whole thing is 25.4. So, what is this inside piece then? What's 25.4 minus 13? 12. Can't be 12.4. 12 point, oh, okay. 12.4. So now can I find what this piece is here? What is this piece? This is 12.4. Now I can add all the outside pieces because I used my, uh-oh. Do we have this piece? Oh, darn it. Now I got to go back and figure out this little piece. How am I going to figure out that little piece? 13 minus 13.7? Correct. So if I do 13.7 minus 9.6, because this inside here is 9.6, what does that equal? 4.1. So then this little piece in here is 4.1. So that means this outside piece is 4.1. Notice that the numbers I don't want to add, I put on the inside just to keep track because I only want to count each length once. So this is 12.4 because it was missing. This piece is 9.6. This whole thing from here to here is a 13.7. I'm not going to add another 4.1 because we were just using that to find this 4.1. And then you'd add this, and then you'd add this. So be careful. Don't double add ones that are already included in your perimeter. So then this would be 12.4 plus 9.6 plus 13.7 plus 4.1 plus 13, right? Did I get them all? Did I put, oh, no, I got to do 25.4. 25.4. And I usually count 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, got them all. And then that'd be 78.2. Try doing number 2. Ah, is this what you got? Hmm? You had a 12.7 from here to here, but I didn't have a length from here to here. Make sense? Okay. Did you everybody get 73.4? Yeah. Okay. I think we did this one. We did this one already. I don't know why. I think this slide got moved. We already did that one. Oh, I want you to try and do 1, 2, and 3. Go and try and do 1, 2, and 3 and tell me what you get. Can I give you a hint for number 1? What do you know about all radii of a circle? All radii of a circle. What do you know about all the radius? They're the same measure. So if CD is 3, what is from here to here? 3. And the whole length is 5. So is this tangent? Is 3 squared plus 4 squared equal to 5 squared? Yes. Because 3 squared plus 4 squared, does that equal 5 squared? 9 plus 16 equals 25. So AR tangent. Oh, she's running. She must be late. So you had to know and you had to be able to apply that because CD is 3 units long, from here to here is also 3 units long. So the whole length had to be 5 units, right? And then we used Pythagorean theorem to prove that this is a right angle right here. And because this is a right angle, then it's tangent. And you do the same thing for this one. But this one you have to factor. No, you don't have to factor. You have to FOIL. So like here, we're trying to check to see if this is 90 degrees, right? So is r squared plus 24 squared equal to r squared or r plus 18 squared, right? So this would be r squared plus 576. And then over here, r plus 18 times r plus 18. R times r is r squared. 18r plus 18r is what? 36r plus, and what's 18 times 18? 324. 24. So r squared plus 36r plus 324. These r's cancel, right? I have 5576 is equal to 36r plus 324. Now what do I do? Subtract 324. 252 equals 36r. So r is equal to 7 because I divide by 36, right? Now here it says it says x squared equals 9. You take the square root of both sides. What you get, x is equal to plus minus 3. But do we use minuses in geometry? No. So we throw out the minus. X has to be 3. I think maybe he's coming, like, I don't know. I guess I should ask him. Okay, so here's another theorem about circles. If one chord is perpendicular bisector of another chord, then the first chord is a diameter. Basically, that's what you guys were finding when you did your first construction with 3 points on the circle. What you were looking for were two diameters that intersect, and they would intersect at the center of the circle, right? If one diameter of a circle is perpendicular to chord, then the diameter bisects the chord and its arc. What does the word bisect mean? Cut in half, right? So if you know that a diameter is perpendicular, hello, then it cuts it into two equal pieces. Okay, Mr. Adam wants your attention. I shall. Um, so we were saying that if a chord has a perpendicular bisector, that perpendicular bisector is the diameter, right? And that if I know it's just a diameter and it's 90 degrees, it's going to be cutting this directly in half. Okay, so how do I use that? If this is 7, right? Then what's FC? 7. Okay? These two would have to equal each other because this is your diameter and it's 90 degrees. So you would say, oh, this would also have to be 7. Correct? Okay. And if they want to know the whole, they want to know AC. AC is the whole length. So what's AC equal to? AC is equal to 14. Now, it also says that it not only cuts the segment in half, but also the arcs that it intersects on the outside. This is an arc, okay? This is what we call an arc. So these two would end up being equal. So 9x would equal 80 minus x. You would add x to both sides. You would get 10x is equal to 80. You would divide by 10. X would equal 8. CD then would be 9 times 8, which is equal to 72. If I did 80 minus 8, good thing I got 72 because I earlier said these two were equal. And that would be in degrees. Well, you just substitute 8 back in. I just substitute. These two had to be equal because this is the diameter and it was 90 degrees. So it cuts not only the chord into two equal pieces, but the arcs that it intersects here and here are also equal. Right? Okay. CE then, well, if if this is 72 degrees and this is 72 degrees, what's 72 plus 72? 144. Yeah, it's talking about the degrees. Because what's a full circle? It's full circle's 360, but this is part of the circle. So this would be 144 degrees. Got it? In the same circle, two chords are congruent if and only if they're equidistant from the center. What does equidistant mean? Same distance. So, since this is 16 here, do you see that? ST is 16. Let me make this bigger so people in the back can see. Since this is 16 and this is 16, these two pieces have to be equal because it has to be the same distance from the center. So you would just, to find CU, you would set 2x equal to 5x minus 9. You would solve for x. You would get 3, and then you just substitute in to find CU, which is 6. So try doing this one. It says in the diagram, suppose ST is 32, CU and CV are equal. They're 12. Find the given length. QR. Well, what's QR if these two are equidistant? Yeah, it has to be 32. I didn't have to do any math. It has to be the same as this. Find UR. Well, what's UR? That's just 16 because these two pieces have to be equal. Now here's the tricky one. Are you confused on why this is 16 right here? You got it? Because the whole thing has to be 32. Plus, this is the perpendicular bisector because it's coming off the center of the circle. So it just cut it in half. To find the radius, this here is 90 degrees, right? So this makes a right triangle. How do you find the missing side of a right triangle when I'm given the legs of 12 and 16? Yep. A squared plus B squared equals C squared. So 12 squared plus 16 squared equals C squared. I think it's going to be 20. But let's see, 12x squared plus 16x squared is 400. And then you take the square roots, a square root of 400, and you take the square root of both sides, you get plus or minus. Because it's geometry, we only worry about the positive. So that'd be 20. Okay, so let's do a couple more together before you do your homework. If this is a diameter, and when they're talking, you got to be careful on the markings with, and if you ever are confused, let me know even on a test because it can get confusing. This yellow piece is 10.4, okay? It's not this one, it's this little piece here. This is your whole radius, and then from here to here is 18. What would this piece have to be if this is 90 degrees and it's the diameter? What's X? 18. I didn't have to do any work. It gave you all that information, but really all you had to notice is that it's 18. Now, when they have X in the center like that, X is the diameter. Okay? So they want to know this whole length here. If this is 5.2 and this is 5.2, how big is the radius? 10.4 is the radius. How would I find the diameter if I have the radius? Multiply by 2. So that would be what? 20.8. And the reason why I know the radius is 10.4 is because this little piece was 5.2, this piece was 5.2, 5.2 plus 5.2 is 10.4, which is the radius. Double it gives you diameter. Okay, again, x is the diameter. So how would I find this one? So 11.1 doubled will give you the radius, right? 22. Can that be turned down? It's really loud. 22.2 is radius. So what's the diameter? Okay. For this one, I'm drawing another radius. Are all radii equal? Spokes on a bike, right? All radii are equal. I'm going to ask that again and everybody say yes. Are all radii of a circle equal? Yes. Okay. So if I draw a new radii, it has to be 12.1, right? Now the problem is it wants this missing piece here. If I find this piece here that's missing and subtract it from 12.1, then I would get x. Does everybody agree with that statement? And this is a right triangle. But now our hypotenuse is given with a leg. So I'm just going to call this as A. So A squared plus 9.3 squared equals 12.1 squared. So I'm going to turn my calculator on. 9.3 squared is 86.49. And then I'm going to have 12.1 squared, which is 146.41. What am I going to do with 86? Wait, that might look like a 6. 0.49 and 146.4. I'm going to subtract. And we get a squared is equal to what? Be 9.92. Is that what you said? Uh, Let me double check. Minus 86.49. 59.92. Yeah, that was right. And now take the square root of that. And we get 7.74, right? A equals 7.74. Is that our answer, by the way? No. What A represents is this part of the radius. But they want the other part, the part that's not making this triangle that I have highlighted. How would I find this missing piece? Yes, I have to subtract 12.1. So it'd be 4.3, yeah, 4.36, 4.36. So some of these take a couple steps. And that's using your deductive reasoning skills. Yeah, that's X right here. Does that make sense? Okay. Okay, so over here, this right here, it says that we're going to assume lines that are tangent are tangent. Lines that are tangent make right angles. So this would be a right angle. This would be a right angle. Now, when it has the question mark here, it's looking for this piece. If it wanted the whole thing, it'd be more in the center. If I find the hypotenuse, I find from here to here, you'd subtract 8. Because from here to here is 8. Because this is a radius. Because all radii are congruent, same measure. So you would do 8 squared plus 15 squared. This will give you c squared, which would be the whole length. This whole length would be c. So 64 plus 225 equals c squared. 289 equals c squared. What's the square root? So c is equal to 17. But that's the whole length. We are going to subtract off the 8 because it wants this piece right here. So 17 minus 8 is 9. So that question mark they were asking for is 9. This one would just do a squared plus b squared. You wouldn't have to subtract off anything. Okay? I'm going to go ahead and give you your, oh, is there more on here? There's more. We did these type, right? Because I want to give you time to make sure you do your homework. Give you enough time. the answers on the back here, but I have an answer key. So I'm going to keep the answer key on this table. And if you need to check your answers, you can just come up here and check them. Okay? You can do that. You want to take pictures of it, that's fine. I just didn't want to have to.
First come, first serve. Okay?
Oh, question mark, because it didn't have a variable.
No argue. No argue. Right? Narrow. Hey, you're narrow, right? Yeah. I never mind. No.
If you want to take pictures of the answer key, that's fine with me.
Narrow.
They're up here. The first one is an example. Yours may look different because you're just finished drawing it.
Cảm nhận đâu?
Oh, I'm sorry. Are you gonna take the test you're missing? Okay, I gotta wait until everybody clears out. I'm not gonna cause you enough to get to my desk.